Hello my dear students, today we learn pair of linear equations. So what is the equation? We have so many polynomials and equations you learn. So first know the difference between the equation and expression. Expression is that 7x plus 9, 8x square plus 4x minus 9. These are the expressions. But these expressions, if they have equal to 0, you can call them as equations. Okay, so these are the equations. In this, these are the equations with only one variable, and these all equations as like a quadratic polynomial, as like a polynomials we divided with the depending on the degree we are divided into some different polynomials. The same way here the degree of the polynomial, degree means the highest power of the variable, especially power of the variable. Here power of the variable is nothing, it means 1. So this is called linear polynomial, and here the power of the variable is 2, so this is called as quadratic polynomial. Here each term has different power, but here you can see that the power of variable is 2, here power of variable is 1, and it is a constant polynomial, there is no variable. So completely highest power is 2, so this is called as degree. So depending on this degree we are differentiating them as a linear, quadratic. If the power is 3, that is called as cubic polynomial. This is the cubic polynomial. So especially we are learning now linear polynomial in one variable and two variables. Okay, first pair of linear polynomials, linear equations, sorry, pair of linear equations, linear in two variables. So before that just we talk about equations with one variable. So equations with one variable, this is the equation, x plus 5 is equal to 0. So x plus 5 equal to 0, it is one of the linear equation because the degree is 1, but it is a linear equation in one variable. Here x plus y minus 7 is equal to 0. This is a linear equation in two variables. Like we can take a different equations. So this is a linear equation in one variable. You know that here x plus 5 is equal to 0. In this, if x is equal to minus 5, if you write, then this equation will be satisfied. It means the left hand and right hand part will get equal. So x equal to minus 5 we are writing here. So minus 5 and plus 5 together, answer will be getting 0. 0 equal to 0, left hand and right hand is getting equal. So this is called a solution of the polynomial, solution of the equation, solution. So this is a, you can understand that linear equation in one variable, it has one solution, that is x equal to minus 5. X equal to, in this equation except 1, you write any number, it never gets a 0. Okay, that's why linear equation in one variable has only one solution depending on the equation. It changes. So one solution only is there. But now this is a linear equation in two variables. So you know the two variables solution, x plus y minus 7 equal to 0. You see that x plus y, x and y. So let us take x is equal to 1, y is equal to 6. So that 1 plus 6 minus 7 is equal to 0. It means 7 minus 7 is equal to 0. So 0 equal to 0. When you write x equal to 1 and y equal to 6, you got the answer here 0 equal to 0. So this is called one of the solution. But like this we can write so many numbers, x equal to 2, y equal to 4, and y equal to 4, y equal to x equal to 4, y equal to 2, sorry, so 3, x equal to 3, y equal to 4, x equal to 4, y equal to 3, and even you can take the number x is equal to 107, y is equal to minus 100. You can take like this. So positive side, negative side you can think, and you can take so many numbers in this list. So this is called linear equation in two variables. So like this you have a infinite solutions. So this is one of the linear equation in two variables. It has infinite solutions, and you know that these all representing in a graph paper you will get a one straight line. So linear equation in two variables is always represents a straight line on the graph sheet. So now you are learning about the linear equation in two variables, but it's a pair of equations. So two equations combinedly you are taking and solving them. Okay, so just we'll see that two equations here. So pair of linear equations, general form. You see first one equation is there, then we will take ax plus by plus c is equal to 0. This is the general form of pair of linear equation. Okay, it has infinite solutions. This is a general form of pair of linear equation. We want pair, so that we are taking that a1 b1 c1 and a2x b2y c2 is equal to 0. This is called a pair of linear equation. Each equation has infinite solutions. Each equation, it has infinite solutions individually. Okay, each equation represents a straight line. So two equations we are taking in our question. So two pair of equations. In these equations, both the equations has infinite solutions, and each equation represents one straight line. Just you imagine how many different types of lines you can draw it on the graph paper. How many different lines you can draw it on the graph paper. You see that here two straight lines. The two lines, if this is x-axis and y-axis, the two straight line, one can be this kind of slanting line. This is a equation 1, and the other one is like in this way. This is a equation 2. So these lines, you know that they are called as intersecting lines. So if two equations you are representing on the same graph paper, they are getting as intersecting lines. The same thing, if two equations, sometime if you represent them, it may get in this way. They are equation 1 and equation 2. These are called parallel lines. And in another time, you can see that the equations, if you represent one of the equation is this, and equation 2 also gets on the same line. Equation 2 also gets here. So three types of lines. These are called coincident lines here. So two straight lines, if you are representing on the graph paper, you are getting either intersecting lines or parallel lines or coincident lines. These three type of lines. So without doing any representation on the graph paper, we can decide whether they are coincident or parallel or intersecting lines. We can decide by a small calculation, that is we can find in this way, that is a1 by a2, a1 by a2, the coefficients of x terms is not equal to b1 by b2, then it is called as, it is a compulsory intersecting lines. But if a1 by a2 is equal to b1 by b2, it is not equal to c1 by c2, it is a parallel lines. So the ratio of coefficients a1, a2, b1, b2, c1, c2, you know that these coefficients, if you are representing here, when they are intersecting lines, a1 by a2 is not equal to b1 by b2, and a1 by a2 is equal to b1 by b2, and but not equal to c1 by c2. So these are parallel lines forming definitely, and all the three are equal. a1 by a2 is equal to b1 by b2 and is equal to c1 by c2, then the lines are compulsory forming a coincident lines, they will get on one another. Here three types of lines are forming, three conditions. Here a1 by a2 and b1 by b2 are not equal, then it is not required to check about the c1 c2. If they are equal, then only check about the c1 by c2 whether it is equal or not equal. So a1 by a2 and b1 by b2 are equal and c1 by c2 is not equal, then they are parallel lines. If all the three are equal, they are coincident lines. You see now, this equation 1 and equation 2 has infinite solutions, but commonly they had only one solution. Here one solution is there, and here these are two parallel lines which never intersects. It means there is a no common solution for them, no common solution. But here you can see the lines are overlapping on each other. If the lines are overlapping on each other, you can say that they are coincident lines, and first line and second line both have same solutions. Infinite solutions are same only, or whatever solutions. The first equation solution is also the solution of second equation. So this is a way we are representing on the graph sheet. Okay, so this is called a common solution for this. Okay, now in this, so this is a condition, so remember that as per this condition we follow that. So see the question here first. What kind of lines forming by the equations now? 5x minus 2y plus 6 is equal to 0. 7x minus 3y minus 7 is equal to 0. So these two lines, when you represent on the graph paper, what kind of lines is going to form? So see now, the first equation, if you take equation 1, here a1, that's a x value 5, and b1 is the y coefficient minus 2, and c1 is equal to constant is a 6, and here a2 here it is a 7, and b2 is minus 3, and c2 is minus 7. So a1, a2, b1, b2, c1, c2. a1 by a2 is equal to 5 by 7, and b1 by b2 is equal to minus 2 by minus 3. Once minus by minus, it gets cancelled, so plus. So minus by minus is plus, so it's a 2 by 3. Here you can understand a1 by a2 is not equal to b1 by b2. So it is called as, so these two lines are compulsory forming a intersecting lines, and they have only one common solution. Okay, so the given lines forms intersecting lines. and they have only one common solution. Okay, so these are the common solution. They had only one common solution. A1 by A2 and B1 by B2 is not equal. That's why here. And we'll go with some examples here. I will show you two more examples, that one is parallel and one is coincident lines. You can see now here. 4x minus 3y plus 6 is equal to 0, and 12x minus 9y minus 14 is equal to 0. You can see that here a1 by a2, a1 is 4, 4 by a2 is 12, 4 ones are 4 3s are 12, so it means 1 by 3 is the answer. And b1 by b2, so b1 by b2 is that it's a minus 3 by minus 9, so 3 ones are 3 3s are, so it is a 1 by 3 is the answer. And c1 by c2, here these both are equal, here it is a 6 by minus 14, so the answer is plus by minus is minus, 2 3s are 6, 2 7s are 14, so 3 by 7. So here I did here first two are equal. I know that when the first two are equal, then we have to find the third one compulsory. We can check that. So first two are equal and the third one is not equal here. A1 by A2 is equal to B1 by B2 but not equal to C1 by C2. So that's why these lines, these equations forms a parallel lines. So parallel lines, how many solutions is there? Parallel lines does not have any common solutions. Just they had individually so many solutions, but commonly there is no solutions. Okay. Next, even one more equation we take here. Five x minus 6y plus 7 is equal to 0, and 15x minus 18y plus 21 is equal to 0. You see these equations here, a1 by a2 is equal to 5 by 15, so that is nothing but 1 by 3, and b1 by b2, it is nothing but minus 6 by minus 18, that is also 1 by 3, and c1 by c2 is equal to 7 by 12, 21. So this is also nothing but 1 by 3. So 5 ones are 5 threes are, 6 ones are 6 threes are, 7 ones are 7 threes are. So here all the three are equal. A1 by A2 is equal to B1 by B2 is equal to C1 by C2 here. So all the three are equal. So these lines forms a compulsory coincident lines. Okay, so coincident lines, they have an infinite number of solutions. So in this we are taking it two equations compulsory forms a different kind of solution. The lines on the graph sheet, so one is intersecting lines, one is parallel lines, one is coincident lines. So intersecting lines means we can say without drawing them we can confirm that what kind of lines they are going to, we can able to draw here. So here the first condition is that intersecting lines, you know that a1 by a2 is not equal to b1 by b2. In that case they have only one common solution. But parallel lines, a1 by a2 equal to b1 by b2 but not equal to c1 by c2. That's, in that case they don't have any common solutions for them. And if this is a third case where a1 by a2 and b1 by b2 and c1 by c2 is equal, all are equal here. So these are called coincident lines. Definitely they form a coincident lines and they have an infinite number of solutions. So okay, so these are the lines Okay, for solving these equations we have a different methods, we'll do in next class. Here these in description we'll keep some questions here. So few questions you can check whether they are the parallel or coincident or intersecting lines. Okay, thank you.